Welcome friends. Today's session will be discussing the equation of continuity, which is valid for the fluids, which is nothing but it's a law of conservation of energy or mass, we can say. And along with this, we'll be seeing what are the different types of energies are there for a liquid. Okay. So let us start with the today's first topic, that is nothing but the equation of continuity. Now, for this equation of continuity, what we will do, we will consider one tube through which the liquid is flowing. For example, let us say this is this tube, okay. This is a kind of a tube through which this liquid is flowing, okay. And as this liquid is flowing, I will just show over here the flow of liquid. It is like this. So, let us say we will consider a two area element. For example, let us say this is the first area element, okay, whose area of cross section is A1. The area of cross section of this element is A. Let us say it is situated at the point P, okay, and there is another area element, let us say situated at a point Q, okay, whose area of cross section is A2, okay. And what we will do, we will assume that the velocity of the liquid at this point, it is V1. Okay, V1 is the velocity of the liquid at point P, and V2 is the velocity of the liquid at point Q. Okay, so this we will assume. Okay, first of all, we will write a description of this figure, and then we will derive what is this equation of continuities. Okay, so consider a tube of flow as shown in figure, the liquid is flowing through the tube at point P having velocity V1 and area of cross section of tube is A1. Okay, so what we have written is that the liquid is flowing through the tube at point P, where the area of cross section of the tube, it is A1, the velocity of the liquid is V1. Okay, let at point Q the area of cross section of tube is A2 and velocity is V2. Okay, so what we are assuming is that at the point Q, the area of cross section is A2 and the velocity of the liquid is V2. Okay, suppose the quantity now see area, if I consider the area into velocity, we know that area is measured in terms of meter square and velocity is measured in terms of meters per second. So if I consider this, I will get this meter cube per second, and we know that meter cube is a unit of a volume. Okay, so if I consider the quantity A1 V1, the quantity A1 V1, it is nothing but, see, A1 is the area, V1 is the velocity. So quantity A1 V1 at point P, it represents the volume per unit second. Is the amount of liquid flowing per second. Is the amount of liquid flowing per second. This is for point P. Similarly, the quantity A2 V2 is volume of liquid flowing per second. At point Q. Okay, so A1 V1 is the amount of liquid flowing through the point P, and A2 V2 is the amount of liquid flowing through the point Q. Okay, now what we will do, if I consider the density of the liquid at this point P1 is ρ1 and the density of the liquid at this point it is ρ2. Okay, and we know that assuming ρ1 is the density at P and ρ2 is at Q. ρ2 at point Q. Okay. Now what we have assumed is this: ρ1 is the density of the liquid at the point P and ρ2 is the density of the liquid at point Q. Okay. Now see, what we have to consider here is this. We are assuming here that liquid has a different density at point P and point Q. If I consider this, what is formula for density? Density is nothing but mass upon volume. Density is nothing but mass upon volume. So if I write it this, rho is equal to mass upon volume. So this will be the formula. We will be using this one. Before that, what I will do, I will consider the quantity. The quantity A1, V1 and ρ1. Now see, just now we have found out this area is measured in terms of meter square. Velocity is measured in terms of meters per second in SI unit, and density is nothing but it is mass upon volume. Mass is measured in terms of kilogram upon volume is measured in terms of meter cube. Okay. So what is this? If I consider this meter cube and this meter square and this meter, it will cancel both each other, and what you will get it is kilogram per second. So kilogram is a unit of mass, okay, and this is unit of time. So if you consider this quantity A1, V1, ρ1, it is nothing but the amount of the mass flowing at a point P per second. Okay, so this quantity we have to consider, that the quantity A1, V1, ρ1 is the amount of mass of liquid, flowing at point P per second. Similarly, if we consider A2, V2, ρ2 is the quantity or is the amount of mass of liquid flowing at point q per second. Okay, so this is the quantity A2 V2 rho 2 is the amount of the mass flowing per second at point q, and A1 V1 rho 1 is the mass of the substance flowing at point P per second. Okay, so now we know, see, if liquid is entering through the point P, it has to go to the point Q only. Okay, because there is a mass conservation, you can say. So whatever the amount of liquid it is going through this point, the same liquid will go into the point Q. Okay, so from this one we can write A1 V1 rho 1, A1 V1 rho 1 is equal to A2 V2 rho 2 is equal to A2 V2 rho 2. But we have already considered that fluids are divided into two types of categories. One is called as gas and another is called as the liquid. Okay, for a liquid, the liquid possesses a property that it is an incompressible fluid. Okay, but liquid is incompressible. Liquid is incompressible. Okay, and for incompressible liquid, we know that its density remains constant. It means whatever the density is at the point P, the same density will be there at point Q. So rho 1 is equal to rho 2. If I substitute this value in this equation, so what I will get? If I substitute these values in this equation, what I will get? Rho 1 is equal to rho 2 is equal to rho. So if I substitute in this equation, I will get A1 V1 rho is equal to A2 V2 rho. Okay, this row and this row on both sides it will get cancelled. From this row we can write A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. That is what A1 V1 we have considered. A1 is the area, V1 is the velocity at point P. Okay, so area is measured in terms of meter square. Area is measured in terms of meter square, and velocity is measured in terms of meters per second. Okay, so we have considered this. It is meter cube per second. It tells us that the amount of liquid flowing at a point P per second is equal to A2 V2. That is the amount of liquid flowing at the point Q. So whatever the liquid it is coming at this point, at the same rate it is flowing at the point Q as also. Okay, so from this one we can write, this implies AV is equal to constant. Okay, AV is equal to constant. From this one we can write, thus the amount of liquid entering at P is equal to the amount of liquid living at Q. Okay, so thus the amount of liquid entering at P is equal to the amount of liquid living at Q. Okay, thus we can have this expression AV is equal to constant, and this equation it is called as the equation of continuity. Whatever it is the amount of liquid at one point it is there, passing the same amount of liquid it will pass at the point another point also. So this quantity AV is equal to constant, that is called as the equation of continuity. Okay, now next what we will consider is when the liquid is flowing, it has different types of energies associated with it. Okay, so we will discuss these types of energies, and we will use these different types of energies of a fluid or liquid while discussing the Bernoulli's equation. Okay, so let us start with the different types of energies involved in a liquid. Energy of liquid. Energy of liquids. In our Newtonian mechanics, we have studied that there are different types of energies are there. So in Newtonian mechanics, we have studied there is a mechanical energy which consists of kinetic energy and potential energy. But in case of fluid, in addition to the kinetic energy and potential energy, we have another kind of energy also, that is called as a pressure energy. Okay, so we will start with the first discussion with the kinetic energy of the liquid. Now, we have studied earlier this kinetic energy of the body. It is nothing but the energy acquired by the body by virtue of its motion. Okay, so first of all we will note it down and then we will see what is the kinetic energy of a liquid flowing through some container. Okay, so it is the energy possessed by a liquid by virtue of its motion. This kind of an energy it is called as kinetic energy. Okay, let us assume that if m is the mass of liquid flowing, with velocity v, then okay, what we are assuming is that m is the mass of the liquid which is flowing with a velocity v, then its kinetic energy is given by okay, all of us know what is the formula for the kinetic energy. Kinetic energy is nothing but the 1/2 mv square. So it is 1/2 mv square is the kinetic energy. Now it is for a total entire liquid. We cannot say what is this quantity exactly. So it is better to express this quantity in terms of per unit volume. Okay, so therefore kinetic energy per unit volume. Okay, so kinetic energy per unit volume is equal to kinetic energy upon volume. Let us say capital V is the total volume of the liquid. Then what I will do, I will just substitute this value in this one. So what I will get 1/2 mv square. Okay, 1/2 mv square divided by I have to divide by capital V. Okay, and if I further rearrange this equation, in this fashion, 1/2 m by capital V, okay, into small v square. But we people know that mass upon volume, it is nothing but it is called as the density of the liquid. Mass upon volume, that is called as the density of liquid. Okay, so if I substitute this m by v as a rho, then kinetic energy per unit volume, I will get the formula for this as 1/2 rho v square. 1/2 rho v square. So this will be the one of the term in the Bernoulli's equation we will be using. Okay, so you have to remember this. Whenever there will be a term 1/2 rho v square, then it is called as the kinetic energy per unit volume. Okay, now we will next move to the next type of energy, that is called as the potential energy. Okay, now next type of energy, that is called as potential energy. That is the second type of energy, that is potential energy. Now all of us know potential energy is nothing but energy stored by an body by virtue of its position or configuration. Okay, so in such a in case of a liquids, what we are having is this. The liquid, when it is at a particular position, due to its particular position, or suppose the liquid is at a certain height h, okay, so it will possess some energy due to its configuration or due to its position. That energy is stored in the form of potential energy. So first of all, what we will do, we will note down the definition and then we will try to find out its formula. Okay, the energy possessed by a liquid by virtue of its position or configuration is called potential energy. Okay, so now in case of, okay, this is called as potential energy. Now for this kind of in order to find out this potential energy, what we will consider a flow of liquid at a particular height, or consider a liquid at height h from the reference surface, height h from the surface. Okay, now see, if I set my reference 0 at this point, so on the surface of the earth, let us say potential energy is 0, then if this liquid is at this point h, okay, suppose the liquid is at this point, okay, whose distance from this surface it is, let us say h, then what you can have, if I say that the mass of this liquid it is m, then gravitational force is acting on this liquid which is in downward direction. Okay, and against this you can say that this liquid is at a height h, so this whatever the gravitational force it will act on this, it is mg. Okay, and against this gravitational force this liquid has been lifted at a height h. Okay, so the work done to bring this object from this surface, this liquid from this surface to this surface, that is mgh, and it is opposite to the work done by it is in opposite direction to the gravitational force, so that work done it will be minus mgh. And now this potential energy, okay, negative of this energy, it is stored in the form of potential energy. So you can write it over here, potential energy, that is negative of that, it will be mgh. Okay, the work done which is stored in the form of potential energy, so it is mgh. The work done by the force, it is negative. Okay, so but this work is stored in the form of potential energy, so it is plus mgh. Now what we will do, instead of potential energy, now we will try to calculate the potential energy per unit volume. Now the potential energy per unit volume, potential energy per unit volume is equal to, let us say this is potential energy, and let us say capital V is the volume of this liquid. Okay, so potential energy has the formula mgh, okay, divided by capital V. So we can rewrite this mass upon volume, but mass upon volume, that is nothing but it is a density of the liquid. So this implies potential energy per unit volume. Potential energy per unit volume is equal to m by v, it is rho, so we can write rho into g into h. Okay, so this will be the next term which we will be observing in the Bernoulli's equation, that is the potential energy per unit volume. Now in addition to this, the third type of energy it will be there, that is called as pressure energy. That is called as pressure energy. Now what is this pressure energy? Okay, the energy possessed by possessed by a liquid due to the pressure exerted by the liquid. Okay, the energy possessed by the liquid, due to the pressure acting, it is called pressure energy. Okay, so it is the energy possessed by the liquid due to the pressure force. Okay, sometimes it is also called as the hydrostatic energy. Okay, so we will not discuss its formula over here, but we will be considering all these parameters while discussing the Bernoulli's equation. So these are nothing but the different types of energies which we had seen when a liquid is possessing, when it is flowing through some container at a certain level. Okay, so that is nothing but the kinetic energy, potential energy and pressure energy. Pressure energy is also called as a hydrostatic energy. All these types of energies we will be considering while discussing the Bernoulli's equation. We will discuss this Bernoulli's equation in our next lecture. Thank you.